Hey, how are you? I'm so glad you can make it. I know it's really coming down outside. I can hear it. It's so loud. I love storms though. I don't know about you, but I just love them. Um, yeah, you seem really stressed out. If you like, I have this lotion that you can use. I really like it. It's like a stress relief lotion. It has in this cool glass bottle. And it's eucalyptus and spearmint. So I really love the scent. Yeah, it's pretty like relaxing and soothing. Yeah, so you can put some on if you like. Sure. And then okay, so I have version B of the math test for 3rd semester nursing. Yeah, you said you went over A already? Okay, good. Yeah, yeah, so, I mean, these are, like, you know, most of them aren't very hard. There's a couple that are tricky, but I know it's kind of stressful because we have to get a 92% to pass, so it can be kind of stressful, especially when they only give you a couple tries. Yeah. Okay, so I have this, and I have some pencils, and I have my calculator. You don't need, like, I have this TI-83 calculator, but I just kind of have it already, so you don't really need this, like, intense of a calculator for this kind of math. But I have it and it works. If you don't mind, I'm gonna actually grab a cough drop because my throat's kind of bothering me a little bit. Yeah, I know it's been, I don't know, my throat has just been bothering me. I'm not getting sick, it's just, I don't know what it is. So I'm just gonna grab like a couple actually, maybe. Do you need one? No, you're okay. Alright. Okay. Yeah, I'm gonna put, I don't know if I'm gonna use them all, but I'm gonna put 3 here. Alright, well, I guess we can get started. Yeah, I did the problems ahead of time because I just wanted to make sure that I was giving you the right information. I didn't want to, like, you know, not know how to do something and have to figure it out. I thought it'd be best to know how to do it ahead of time, so I checked the answers that I got and they were right, which is good. Oh yeah, so anyway, let's get started again. Alright, the first problem says a 0.003% solution can be expressed as a fraction, and then it wants us to put the fraction or a ratio. So it's always it's always a good idea for these kind of problems to remember that a 1% solution is 1 gram over 100 milliliters. If you can remember that, then you can look at these problems, and sometimes this one actually is, like, I feel like it's one of the harder ones because you kind of look at it and it kind of looks confusing. But if you can remember that 1% is 1 gram over 100 milliliters, you can always just kind of figure it out. So knowing that, we would have 0.003 over 100 milliliters. The thing about this is that we don't want decimals in a fraction. Oops, sorry. So, I mean, I think They went over that in like 3rd or 4th grade, but you kind of forget that stuff if you don't use it. So we want to move the decimal over, so we're going to end up moving it over 3 spaces, which means we need to add 3 zeros to the milliliters. So our final fraction will be 3 over 100,000. And then basically the ratio is kind of the same thing, the same story, but it's just side by side instead of on top. So it's 3 to 100,000. Sorry. So yeah, so you can kind of take a look at that if you want. Does that make sense? Yeah. Okay. Alright, so moving on. Problem number 2 says that 25 milliliters of a 0.2% lidocaine HCl has been administered to a patient. The patient has received how many grams of lidocaine? So, we know that there are 0.2 grams of lidocaine in 100 milliliters. Then, and here I am having the decimal and the fraction, but I don't care. Then, how many grams are in, I'm going to use X here, in 25 milliliters. So we can just use cross multiplication to kind of get our answer. So we end up with 0.02 times 25 over 100x. Okay. I'm sorry, that's not right. I don't know what I was thinking. Well, actually, technically it is right, but it just is not helpful. Equals 100x. Alright, so then we want to divide by 100. So let's grab the calculator. And, sorry, I can't really see it. Okay, so we've got 0.2 times 25 divided by 100 equals 0.05. So the answer to this one is 0.05 grams. And then we want to make sure that they actually wanted grams, because I think sometimes they like to try and trick us and put milligrams. So it's a good idea to just make sure that we have the right thing going on there. Okay. Question 3 says D5W with Dobutrex is infusing at a rate of 36 milliliters per hour. The IV solution was prepared by adding 250 milligrams of Dobutrex to D5W. The final solution contained a total volume of 750 milliliters. How many milligrams are infusing per hour? How many milligrams are infusing per minute? Okay, so with this one, we know we have 250 milligrams in 750 milliliters. So what we want to know is how many milligrams are in 36 milliliters, because that's how many are infusing into the patient. So we can set this up by cross multiplying again, our dear old friend, and divide by 750. Okay, so we're gonna come over here and we're gonna multiply 250 times 36 divided by 750. So we have 12 milligrams infusing into the patient per hour. And then to find out per minute, we want to divide by 60, and we get 0.2 milligrams per minute. And that's our answer. Alright. Number 4. 350 milligrams of Cipro 4 has been added to normal saline. The final solution has a volume of 200 milliliters. You realize that the IV solution contains how many milligrams of Cipro per milliliter? So this one is actually really simple. The thing I like about word problems, when I was younger, I didn't like them at all, but now I like them because I can look and I can ask myself, does my answer make sense? And in this context, it's not that hard to decide whether or not your answer makes sense. It's kind of nice. So we just need to know how many milligrams per milliliter we have. So we're going to divide 350 milligrams by 200 milliliters. And we have 1.75 milligrams per milliliter. There we go. Okay, next question. Says 0.5 grams of Zantac must be prepared. Zantac is available in milligrams. How many milligrams of Zantac should be prepared? This is another one that's really pretty easy. All you have to do is remember that that there are 1,000 milligrams in a gram. So if we have half of a gram, then we have half of 1,000, which is 500 milligrams. This is kind of just making sure that we know how many grams or how many milligrams are in a gram. Another thing that will be covered later is micrograms. And I kind of have a funny way of remembering micrograms. But it seems like the main gram units that we cover in this math exam tends to be grams, milligrams, and micrograms. So each one is just divided by 1,000. So if you have 1 gram, you have 1,000 milligrams, and you have 1,000,000 micrograms. So there's that. Okay, the next question says you have available 1 milliliter ampule of promethazine labeled 100 milligrams and 1 milliliter. 75 milligrams of promethazine must be prepared. how many milliliters of the drug should you prepare? So this is actually a pretty simple one too. If we have 100 milligrams in 1 milliliter, and we need 75 milligrams, how many milliliters is that? We end up having 75 milligrams divided by 100 basically, and it turns out to be 0.75 milligrams. So that one is pretty simple. Actually flip my notebook too. Okay, oh, you know what? I'm sorry, I almost skipped number 7. Okay, number 7, this one is also really easy. It's an adult weighs 157 pounds. You determine that 157 pounds is equivalent to how many kilograms. So really here we just need to know the conversion, which is 2.2 kilograms per pound. So if we divide 157 by 2.2, we end up with 157 divided by 2.2, we end up with a 71.36, and it's like repeating. So I think I looked at the answers and we're gonna go with 71.4. Just so you know, I noticed last time on the exam that that the final, they usually told us where to round. So for this problem, they would have said round to the nearest tenth. So 1 space is 10, 2 is 100, and 3 is 1,000 after the decimal. Just in case you need a review on that. Okay, so the next question says that 100 milliliters of 1/3 strength delivered to must be prepared for tube feeding. You have available full strength delivered to. To prepare the feeding, you dilute how many milliliters of full strength delivered to with how many milliliters of water. So this one's also pretty simple, really. All you do is you have 1/3 times 300, because we want 1/3 of the final solution to be delivered to. And what we come up with is 100 milliliters, and then the remainder is water, obviously, so 200 milliliters of water. We want that to equal 300 altogether, so there we go. Okay. Okay, the next question says, you need to verify that a prescribed dose of furosemide for a patient is currently weighing, you need to verify that a prescribed dose of furosemide for a patient currently weighing 21.1 kilograms is appropriate. The drug literature recommends 2 to 3 milligrams per kilogram per dose. You determine that an appropriate dose for this patient would be how many milligrams. So we need to figure out we need to figure out a range basically. So the lower range says 2 milligrams per kilogram. So we just take our 2 and we multiply it by 21.1, and then we're also going to need to multiply 3 by 21.1 to get our upper range. So I'm just going to do them both right away. So we have 42.2, and then that's the lower range, and then I think it says here, yes, it says round to the nearest whole number, so we're going to go with 42 milligrams as our answer for the first part. And then we have 3 times 21.1. So our upper answer is 63.3, rounded to just 63 milligrams. So 42 to 63 milligrams. Yep. Okay. You need to verify that a prescribed dose of quinidine for a patient currently weighing 30.3 kilograms is appropriate. The drug literature recommends 3 milligrams per kilogram per dose. You determine that an appropriate dose for this patient would be how many milligrams per dose. So, same story, we just take 30.3 and we multiply that by 3, which would give us 90.9, and we want to round to the nearest whole number, so our answer is 91 milligrams. Number 11, liquid loxetane C is available for PO use, labeled 30 milligrams in 5 milliliters. 150 milligrams of loxetane C has been prescribed. You should prepare how many milliliters of the drug for administration. Okay. So, with this one, it's not too complicated. We just need to know, basically, we can divide 150 milligrams by 30 milligrams, and then that's per 5 milliliters, so we can multiply that by 5 to get our answer, because we need to know how many milliliters total. So here we go, 150 divided by 30 is 5 times 5 is 25. 25 milliliters is our final answer. Number 12, 1.5 tablespoons of cough medicine has been prescribed. A measuring device marked in milliliters is being used. How many milliliters should be administered? Okay, so for this one, we need to remember that there are approximately 15 milliliters per tablespoon. And while we're discussing it, we could go ahead and talk about how there are 5 milliliters in a teaspoon. So right here we have 15 milliliters times 1.5, and here we can find out this how many milliliters we need. So we take this here, 15 times 1.5, 22.5 milliliters. There we go. Okay. To maintain cardiac output, dopamine in D5W is being titrated 200 to 500 micrograms per minute. The IV solution was prepared by adding 0.5 grams of dopamine to D5W. The final solution contained a total volume of 300 milliliters. You should infuse the IV solution at a rate of what to what? Okay. So we're working with micrograms here. Like I said before, if we have 0.5 grams, that means we have 500 milligrams, and we have 500,000 micrograms. I'm just gonna translate that right over so that we don't have to worry about the conversion anymore. And we know that that is in 300 milliliters of solution. Okay, so what we want to know is how many milliliters contains 200 micrograms. So we can cross multiply again. So we would get 200 times 300 divided by 500,000. And it's important that we realize that the question, the way it's worded, it says 200 to 500 micrograms per minute, and we're figuring out how many milliliters per hour. So we need to multiply the answer of this, which is 0.12, by 60 to get the hourly rate, which is 7.2 milliliters, and that is our lower end. And now our higher end answer for our range is 500 times 300 divided by 500,000. And then we get 0.3 and multiply that by 60 because 0.3 is the rate by minute. And we have 18 as our final answer. So the range is 7.2 to 18 milliliters per hour. Okay. Hey, we're halfway through. Alright. So, I think I might switch pencils because that one is getting dull. Okay. The next question. Oh, I have to flip my notebook too. The next question states, an IV solution contains 6 grams of bradolol. 6 grams of bradolol is equivalent to how many milligrams? So this one is really simple. This again is just proving that you know that there are 100 or 1,000. See, I don't know. 1,000 milligrams per gram. So we just multiply the 6 by 1,000, and we get 6,000 milligrams. That is our answer. Okay, the next one says a 1 to 10,000 solution for external use prepared from a solid drug contains how many grams of drug per 10,000 of solution, or how many grams of drug for every milliliter of solution. So we have to remember that this 1 to 10,000 means that there's 1 gram for 10,000 milliliters. So it already gave us the first answer. Basically it's just making sure we know what this means, and it's important, I don't know if I said before, it's important to remember that it is 1 gram over milliliters here. That is the default, because I think people tend to think it should be milligrams and milliliters, because that would make sense, but nothing really ever makes sense. So it's 1 gram over the default is 1 gram over 100 milliliters is a 1. Well, I shouldn't say that's the default, but that is a 1% solution. This is a lot less than a 1% solution. So and then the other question, the other part of the question is how many grams for every milliliter. So we just need to divide 1 by 10,000, which I think we just move the decimal over, but yeah, that just tells us e negative 4. So we can say it's 0.0001, and you can check that by 1, 2, 3, 4, counting how many spaces it would take to get you behind that 1. So it's that many grams per milliliter. And then, you could always go back and check your work, kind of pick a different number in the equation that's given to you and plug that in. Remember your high school algebra or whatever, where you can just kind of try to find a piece to the original equation by using your answer to make. That's how you can make sure it's right. Okay. Next question says dopamine is to infuse at a rate of 23 micrograms per kilogram per minute. Your patient's current weight is 51 kilograms. How many micrograms of dopamine should be infused per minute? Okay, so this is pretty simple. First of all, I'm just going to make sure that it says per minute, and this one also says per minute, so we don't have to worry about converting that part. The next thing is that it's asking us how many micrograms, and this is giving us micrograms, so that's good too. And this gave us kilograms, not pounds, and this says kilograms. So we just take 23 and multiply it by 51. Okay, so over here, 23 times 51, 1,173 micrograms per minute. And there we go. Okay, number 17. 35 milligrams of liquid bentyl has been prescribed. 35 milligrams is contained in 10 milliliters. A measuring device marked in teaspoons is being used. 10 milliliters is equivalent to how many teaspoons? So, once again, we need to remember that there are 5 milliliters in a teaspoon. Remember that? You're golden. So, all we really need to do is we need to give 35 milligrams, and they told us that 10 milliliters equals 35 milligrams. So we know that 5 goes into 10 twice, so we come up with 2 teaspoons, which will give us 5 milliliters, because each is 35 milligrams. Number 18 says an infant weighing 8 pounds 11 ounces. An infant weighs 8 pounds 11 ounces. You determine that 8 pounds 11 ounces is equivalent to how many kilograms. So this part, it's always important to remember that you need to convert that 11 ounces over to a decimal of pounds. Since there are 16 ounces in a pound, versus if it was 10, you could just, well, that wouldn't make sense with 11, but if it was 10, you could just do a decimal, take the ounces, and do like 8.9 if it was 8 pounds 9 ounces. So we just need to divide 11 by 16, and we get 0.6875, and then I'm going to add 8. And now we have 8.6875. Now to get kilograms, all I need to do is divide by 2.2 again, and I end up with 3.94886. So I'm going to round to the nearest 10, which is 3.9 kilograms. Okay. Alright, we're getting there, hey? You need a break? No, you just want to power through? Me too, okay. Alright, number 19 says Dobitrex is to be infused at a rate of 8.2 micrograms per kilogram per minute. 0.9 grams of Dobitrex has been added to D5. The final solution has a volume of 200 milliliters. Your patient's current weight is 36 kilograms. The IV should be infused at how many milliliters per hour? So, with this one, we just want to, okay, sorry, I was just trying to figure out. Okay, so we want to convert, this is how I like to do it anyway. I like to convert the grams over to micrograms, so that I don't have to worry about converting that later. And then we know that there are that many micrograms, or 0.9 grams, in 200 milliliters. Okay, so we want to put that down there. And the next thing is we need to find the dose that's safe for our patient. So it says to use 8.2, so multiplying 8.2 micrograms per kilogram, and the patient is 36 kilograms, so that ends up being 295.2 micrograms. So I'm going to put that up here. Okay, and we're trying to find how many milliliters contains 295.2 micrograms. So we just can cross multiply, and I'm not going to write it out this time because it takes up too much space. So 295.2 times 200, and then divide that by 900,000. So this gives us 0.0656. Now that is the milliliters per minute. So we need to multiply that by 60, and it will give us 3.936. And I believe they want us to round 4. So 4 milliliters per hour, which is really slow. But yeah, so that's the answer. Alright, the next question says you have available an IV administration that delivers 15 drops per milliliter. Lactated Ringers has been prescribed to run IV at a rate of 700 milliliters over 7 hours. The IV should infuse how many drops per minute? Okay, so these problems I feel like are pretty easy once you understand them. The drops per mil, the drip factor, is basically just telling us, well, exactly what it says, that it takes 15 drops from this IV tubing to equal a milliliter. So once you kind of understand that, then the whole drop factor thing makes a lot of sense, because we need 700 milliliters over, well, 700 milliliters times 15. That would give us how many drops we need to infuse into the patient in 7 hours. And we want to know how many per minute. So we want to divide that by 7 times 60, because we need to know how many minutes are in 7 hours. So I'm just going to do that on the calculator. Man, it's really like storming pretty hard out there. Okay, so we end up getting 25 drops per minute. So I hope that made sense. 700 milliliters over 7 hours, and then we have 15 drops equals a milliliter. So this is how many drops per 7 hours, and this is the time, basically the minutes that we're running it over. So there you go. Okay, the next question says a 5.5% solution can be expressed as a fraction or a ratio. So they just want us to write out what the fraction is. And once again, we want to remember that 1 gram over 100 milliliters is equal to a 1% solution. So I feel like this is just kind of, it's a little foreign for most people. I know it was for me. And so when I would see that, I would kind of freak out a little bit, like, oh my gosh, what does that even mean? But we can see here that it's, as long as we have this memorized and we remember that, we're okay. So because we know this, we can say that it would be 5.5 over 100, and we don't like that decimal in there, so we can do 55 over 1,000. Now, I know, and I may made this mistake earlier because I forgot. They want the least common denominator. So that means we can divide both of these by 5 and we end up getting 11 over 200. That's our fraction, and then we just move it side by side for the ratio. That's it. Oh, we don't have much left. Okay, so the next question says an IV of D5 containing 5 milligrams of bisupro and a total volume of 425 milliliters is to be infused at a rate of 10 micrograms per minute. At how many milliliters per hour would you infuse the IV? Okay, I need to switch over my notebook, sorry. Alright, so we're trying to figure out an answer that's in micrograms. So I'm going to right away look at this milligrams, 5 milligrams, and I'm going to convert that over to micrograms. So we have 5,000 micrograms, and it is in 425 milliliters. Okay, so we're wanting to know what rate would give us 10 micrograms per minute. So we want to know how many milliliters would hold 10 micrograms if there are 5,425. So once again, we're going to cross multiply, and I'm just going to do that over here on the calculator. And we find out that there are there's 0.85 milliliters per 10 micrograms. And in order to get our answer, we multiply that by 60 so that we get it our rate in hours instead of minutes. And it turns out that we need 51 milliliters per hour. And there we go. Okay, number 23. 375 milliliters of 1/3 strength hepatic aid 2 must be prepared for tube feeding. You have available full strength hepatic aid 2. To prepare the feeding, you dilute how many milliliters of the full strength of hepatic aid 2 with how many milliliters of water? So we need 1/3 strength again. So we need 375 milliliters of 1/3 strength to be our final product. So 1/3 of 375 milliliters needs to be the hepatic aid, and then 2/3 needs to be water, obviously. So we're going to multiply 375 by 1/3, and I think that will be 125, right? Yeah, 125 milliliters of the hepatic aid 2. And then to get the water, I'm just going to multiply that by 2. 250 milliliters 24. An IV will be administered using an infusion pump that delivers milliliters per hour, D5 and 0.1% NaCl. Has been prescribed to run an IV rate of 300 milliliters in 12 hours. The IV rate should infuse at how many milliliters per hour? This is pretty simple, really. All we need to do is divide 300 over 12 hours. So 300 divided by 12 equals 25 milliliters per hour. That was pretty straightforward, I suppose. Okay, number 25. An IV will be administered using an infusion pump that delivers milliliters per hour. D2.5 has been prescribed to run at a rate of 900 milliliters over 15 hours. The IV should infuse at how many milliliters per hour? This one's pretty much the same as the last one. Okay, so we have 900 milliliters over 15 hours equals 60 milliliters per hour. And there we go. That's it. Alright, well, I guess that's pretty much it. If you want, we can review you want to review the conversions? Okay. Alright, so it's important to remember that for 1 pound, opposite. 2.2 pounds is equal to 1 kilogram. So remember that one. And then we have 5 milliliters equals a teaspoon. Oops. Okay, and then 15 milliliters equals a tablespoon. And then, what were the other ones? Oh, a 1% solution is equal to 1 gram over 100 milliliters. And then there's the drip rate equation, which gives us the rate times the drop factor over time equals whatever our answer is. And just make sure you pay attention to what the final answer, the units of the final answer are going to be. I think that they usually put it in on this test, so you'll just put a number in. You don't have to put the units, but it's just important to check and make sure that you have the right unit. And then, yeah, just remember this stuff. I think you're gonna do great. I think it's gonna be just fine. Yeah, everything's gonna be fine. You're gonna pass, and all will be well. Great. Okay. Alright, well, thanks for coming over. I'm glad that I was able to help out. You have a good night.